Welcome guys. In this video, we are going to solve some questions on the first category of questions we can get under regular expressions. So first on our list, we have to write a regular expression for all strings over the alphabet AB that starts with an E. So for better understanding, we are going to write the language of the question. Question requests for strings that starts with an E. It implies that our strings must start with an E, but it can end with any other symbol. It can end with either E or B, and it can reoccur. It can be any number of times. It can have E as part of our language since it starts with an E and ends with nothing. We don't care about what it ends with. And that's the only string of length 1 we can construct from our alphabet. We move on to strings of length 2. We can have EE, which starts with E and ends with E. We can have AB, which starts with an E. And now our strings of length 2 is also exhausted. We can have BA or BB because they both don't start with an E. So they are not part of our language. Now to strings of length 3, we can have AAA, AAB, ABA, and ABB. The rest of the combinations will not be accepted by our language because they start with AP. So this is an infinite language. We can go on and on and on. Strings of length 4, 5, 6, more. So now let's try and write down our regular expression. So we can see each of them starts with an E. So we first write down our E, and then it's followed by an A or a B, and it can be any number of times. So we use the star operator to implement the recursion. So this is the regular expression for this question. So in trying to determine the regular expression, we can write down our language and connect them using the union operator. We can clearly see that with each string, it starts with an E. So we can factorize our A out. From there, what's left is an epsilon, that's the empty string attached to the first character E, although it wasn't directly written. Or we have an E attached to the second string, or AA, or AB, or BA, or BB, and this can go on forever. So what does this represent? We said earlier that the clean closure consists of any possible combinations of the alphabet, including epsilon, which is the empty string. So we can rewrite this as A followed by the clean closure of our alphabet. To break it down, our alphabet comprises of A and B. So let's substitute the symbol with A and B in union, and let's attach our clean closure. So that was just to break it down for further understanding. Let's move on to our second question. Write a regular expression for all strings over the alphabet AB that end with B. Like before, we are going to write down our language. So the question requests that our set of strings should end with a B. This implies that we don't care about the symbol it starts with and the number of times it occurs. So we can have B, which starts with an empty string and ends with B, AB, BB, and so on and so forth. So this is also an infinite language. From our language, we can see that each and every single string ends with a B, but I can start with either epsilon, A, or B, which is nothing but A or B star. So the question is as simple as that. Moving on to the next question. We have to write a regular expression for all strings over the alphabet AB that starts with an A and ends with a B. So this time we'll write down the language. So what does the question imply? It implies that our strings must start with an A and end with a B, but we can have any combination of strings between them, including nothing between them, that is the epsilon. So it's nothing but the clean closure of our alphabet between A and B. So now let's substitute the symbol with our alphabet A or B, and let's retain our star operator. This is the solution for our third question. On to question 4. We have to write a regular expression for all strings over the alphabet AB of length at least 3, where the third character from the left is an E. So this question demands that we have strings of length 3 or more, where the third character is an E. So we can have strings of length 3, where the third character is an E. Or we can have strings of length more than 3, but the third character must be A. So in solving this question, we can have A or B for the first character, followed by the second character, which can be A or B, and then followed by a third character, which should be A. And then after the third character, there can be any combination of the alphabets, including nothing at all. That's the epsilon, the empty string. And that is nothing but A or B closure. So the trick here is to put two alphabets in juxtaposition with each other, followed by the third character, which must be A. And then there should be closure of our alphabets to allow strings of length more than or equal to 3. Now on to question 5. Write a regular expression for all strings over the alphabet 0, 1 that do not contain the substring 0, 0. So how do we go about this question? The question implies that we can have any combination of ones, but we can't have two consecutive zeros. So the trick here is to prevent the occurrence of the second zero whenever we see a 0. So we can have a 1, or whenever we see a 0, we follow it by a 1 immediately to prevent the occurrence of a 0. And we can have this occurring any number of times. And to allow for a case where it starts with 1 or 0, 1 and ends with a 0, we can add an optional 0 at the end. So this is how we represent optionality, as stated in the previous video. So it means that we can have 0 or the empty string, that's nothing at all. So that is the trick to this question. So in a question where you are allowed to use more than the 3 co-operations, you can represent it with the optionality operator like this. So let's test this out. We can have 1 as part of our language, or 0, 1, or any combinations of 1, or any combinations of 0, 1. The case where we pick 2 1s from the first bracket and 2 0 1s from the first bracket again, and we want to end with a 0, we can pick that 0 from the last bracket. So that is why there is the optional 0 at the end. So that is the solution to this problem. 0, 0 cannot be accepted because we can only pick 1 0 from the optional 0. Question 6. Write a regular expression for all strings over the alphabet A, B, C that does not contain the string AA. So like the previous question, the trick is to prevent the occurrence of two consecutive A's. So wherever we see our first A, we have to combine it. So wherever we see our first A, we have to concatenate it with any other symbol apart from A. So we can have B or C, but wherever we see one A, to concatenate it with a B or a C, any other symbol apart from A. And this can reoccur any number of times. But we have to concatenate an optional A at the end to allow for any combination of B or C or AB or AC that ends with an A. So this can also be represented by the optionality operator, A followed by a question mark, to represent an optional A. Cases where you are allowed to use extensions. On to our next set of questions. With this set of questions, we'll be given the regular expression and we'll have to describe it in English. Question 1. We have A or B star followed by AA or BB. So here we can assume that our alphabets are A and B, since they were the only alphabets that were used in the regular expression. So according to the regular expression, we can start with any combination of our alphabet, including the empty string, and it must end with 2 consecutive A's or 2 consecutive B's. So we can see that our regular expression matches all strings over the alphabet AB that end with 2 consecutive A's or B's. You can see that ends with 2 identical characters. It's the same thing. To our next question, we have A star, B star, C star, and we have to describe it in English. We can assume that our alphabet is A, B, C, because those are the only symbols that were used. So for this regular expression, we can have any number of A followed by any number of B's followed by any number of C's, including not the epsilon. So this implies that we can have C followed by B or B followed by A. As part of our language, we can have no A at all, followed by 2 B's, followed by 3 C's. We can have no A's or no B's, followed by 4 C's. We can have 1 A, followed by 1 B, followed by 1 C. We can see clearly that it's simply a regular expression that matches all strings over ABC that are in alphabetical or sorted order. So try and understand these questions before you move on to the next category of questions. You can rewatch this video because it gets increasingly difficult in the next category.